Number 9, we have a car rental situation, trying to find what the slope and the y-intercept signify. The y-intercept is 45, and that's the value when x is equal to 0. So when you haven't even driven any miles at all, x is 0, you're still paying $45. So $45 is the cost per day to rent the car, and then the slope is the number multiplied by x. So it's the cost per mile. For every additional mile you drive, you're going to pay an extra 15 cents. For number 10, solve both of these individually. So subtract 3 from both sides, and here add 5 to both sides. And it says and, so x has to meet both of these conditions. So x is sandwiched in between -2 and 3. And you want to make sure to use the brackets with 3 because it's okay for x to be equal to 3. For number 11, we're finding a line that goes through this point and is perpendicular to this line. So let's start by finding the slope of this line. We're going to try to put it in y equals mx plus b form and get y by itself on the left. So to first start that, we're going to subtract the 2x from both sides, and we'll get here. And then divide both sides by 4, and you'll get to here. And that's in y equals mx plus b form, so we can just look and see what the slope is. It's -1/2. So a perpendicular slope would be a +2. Flip the fraction over and change the sign. So for our line that we're trying to find, it's y equals 2x plus b, because we know the slope is 2. And then we know a point it goes through, so plug the y and the x values in, and then solve for b. So add 2 to both sides, b is 6. For number 12, we're looking for the equation of a line that goes through these 2 points. So let's start by finding the slope of the line. So subtract the y's on top, y minus y, and subtract the x's on bottom, first x minus the second x. And so you'll get a 1 on top and an 8 on bottom. So the slope is 1/8. So we have y equals 1/8 x plus b using slope-intercept form. So plug in either one of these points in and solve for b. And I chose the point that has all positive values. So put the y and the x in. You'll get to here, and then subtract a half from both sides, and you know what b is. And your final answer. For 13, we have a compound inequality. So solve them each separately. For the first one, get the x's together, so subtract 3x from both sides, and then add 6 to both sides, and then divide both sides by 6, and you'll get x by itself. So x is less than 1, or for this one, divide both sides by -4, and you'll get x is greater than or equal to 3. Make sure you switch the sign when you divide or multiply by a negative number. And so in interval form, it would look like this. You use the parentheses around the 1 because x is strictly less than 1, and a bracket around the 3 because x is greater than or equal to 3. So you want to include 3 in the answer. And then in graph form, you're just shading in the numbers that are part of the solution. Make sure you do a bracket at 3 and the parentheses at 1. For number 14, identify the slope in the y-intercept. The slope is the number in front of x, so -2/5. And the y-intercept is the number at the end, so as a point, it's 0, -5. And then so graphing it, the intercept is 0, -5. And the slope you're going down to over 5. And it would look like that. For number 15, we're graphing an inequality here. So the first thing you want to do is distribute the 4 through and multiply by everything inside the parentheses, and I did that here. And I'm using y's and x's instead of function notation because I think it's easier to graph when you use y's and x's. So now you can combine these two numbers and you'll get to here. So the first thing you want to do when graphing is graph the border line. So with an equals symbol, we'd have this equation. Our intercept is -5. And our slope is 4, so we go up 4 over 1, and we draw our line. Draw the line solid because it's greater than or equal to. So we would dash it if it was just greater than, but because it's greater than or equal to, the line is actually part of the answer, so we need to draw it in solid. And then we need to shade either above or below the line. And if one point up here works, then they all work. So pick a test point, and I'll pick 0, 0, and plug it in. So we're plugging it into our inequality, 0 for y and 0 for x, and you get, is 0 greater than or equal to negative 5? Yes, yet it is. So since that point made the inequality true, all the points above will make the inequality true. So color them all in to signify that any point up here is an answer to that.